Okay, so here's what we're going to do. We're going to look at common radian measurements. Okay, this is extremely important. Lots of students, when they begin a trigonometry course, will always want to think of radians in terms of degrees. And we've got to shift that focus from degrees because a lot of our work will be in radians. So this is how you do it, okay? So what I want to do first is recall the relationship between degrees and radians. So 1 revolution in degrees is 360 degrees, but in radians is 2 pi radians, okay? So 360 degrees is the same thing as 2 pi radians. So that's a full revolution. So what that means is it's often easier to think of radians in terms of pi radians. So if you do half of a revolution then from 0 to the negative x-axis, you get pi radians. Okay? So pi rads equals half of a revolution, or 180 degrees. So let's start thinking about cutting the plane into various radian measurements. So let's do an example first, okay? Let's say we want to cut the plane into pi over 2's, okay? Into pi over 2's. So here's how we could think about that. Those instructions are a bit vague, but what we're going to do is we're going to start with the x-axis and the y-axis to get our plane. We're going to locate 0, okay? But instead of calling it just 0, let's call it 0 pi over 2, because that also equals 0, but we want it in terms of pi over 2's. So that's 0 pi over 2. Now, if I were to rotate all the way around here, that would be pi, right? I don't want all of that. I want pi over 2. So I'm literally going to rotate half of a pi. So these are half pi's. So the first half pi that I hit is right here on the positive y-axis. Didn't give myself enough room here. So the positive y-axis is going to be my first pi over 2, my 1 pi over 2. And then I'll rotate another half pi, which is going to put me here, and so I can call that 2 pi over 2. It's just an additional pi over 2. You might notice that 2 pi over 2 reduces to pi, which is good for us because we know pi is right here on the negative x-axis. It's half of a revolution. But I want it in terms of pi over 2's, okay? If I keep going, then I get 3 pi over 2, my third pi over 2, and then I get 4 pi over 2, which you might notice again reduces to 2 pi. Okay? So you could of course keep going, then you'd have up here 5 pi over 2, and then 6 pi over 2, 7 pi over 2, etc. Okay? So that's how you cut the plane into pi over 2's. Pretty easy. They keep hitting all of the axes. They're basically 90-degree rotations. I don't want you to think of it in terms of degrees. I want you to think of it as starting with pi and then cutting pi into this many pieces. So we cut pi into 2 equal pieces. Halves, if you will. Alright, let's try another one. Cut the plane into pi over 4's, okay? And so this time, here's 0, here's pi. I want to cut this top half into 4 equal pieces. So 4 equal pieces is what we're looking at. Alright? So if I look at that, the first thing I'm going to do is cut the top into 2 equal pieces. And of course those are pi over 2's. But then I need to cut each of these into 2 equal pieces again. Like this. And now I have 4 equal pieces. I've cut my pi into 4 equal pieces. So that means, now when I look at this, this is 0 pi over 4. I'll rotate 1 pi over 4, so this is 1 pi over 4. I'll rotate another, giving me 2 pi over 4. Rotate another, 3 pi over 4. And finally, 4 pi over 4. And you can see that if you reduce that fraction, you get pi. But let's go ahead and continue this. Let's cut the whole plane into pi over 4s. You can see that these give you 45-degree angle rotations if you think in degrees, just to make the connection there. So this will be 5 pi over 4, then you've got 6 pi over 4, 7 pi over 4, 8 pi over 4, which reduces to 2 pi. Okay, so you start to notice some basic ideas. Okay, you get here. Let's do this. Let's take a break from cutting pi into pieces. We've done pi over 2s and pi over 4s. Let's back up a moment and let's look at cut the plane into pies. Okay. If we cut the plane into pies, here we go. We know 0 pi is here, and we know half of a revolution is 1 pi. So we're going to get 0 pi, then we're going to get 1 pi. Do another half revolution, we're going to get 2 pi. Another one, we're going to get 3 pi, then 4 pi, 5 pi, 6 pi, and we start to see a pattern, hopefully. We get over here on the right side of the plane, we get even pies, right? 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, etc. Over here on the left side of the plane, we get odd pies. That's really important to help us quickly identify some things later on. So make sure you know that all the even pies are on the right and all the odd multiples of pi are on the left. Okay, let's proceed. We're almost done. Let's cut the plane into pi over 3s, okay? So we've got 0 pi over 3. Let's just think of it as 0 momentarily, and then think of pi. I always think of 0 and then pi. Because when you look at pi over 3, you're thinking divide pi into 3 equal pieces. Divide pi into 3 equal pieces. So that means I'm going to have maybe there's 1/3 of pi, there's 2/3 of pi, and there's 3/3 of pi. So each of these is equal. Okay, so we get 0 pi over 3, then we get 1 pi over 3, 2 pi over 3, and 3 pi over 3. If we keep going, we get 4 pi over 3, 5 pi over 3, and 6 pi over 3, which again reduces to 2 pi. Okay? So those are cutting the plane into pi over 3s, which are 60-degree rotations, okay? Let's cut the plane into pi over 6s. So you've got 0, you've got pi. We need to cut the top half into 6 equal pieces, which is equivalent to cutting each quarter into 3 equal pieces. So there's 1 piece, 2 pieces, 3 pieces. And then I'll proceed to do that through every quadrant. And each of these is a pi over 6. You can see that there are six splits, 6 cuts for the top half. So those are pi over 6s. Sorry, it jumped like that. Then we proceed to do the others. So what we have here is 1 pi over 6, 2 pi over 6, Notice that that reduces to pi over 3, which is what we had up here. 3 pi over 6, which reduces to pi over 2. 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6, and 6 pi over 6, which reduces to pi. And of course, you keep going. You've got 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6, and finally you get 12 pi over 6. Okay? So this is cutting the plane into common radian measures. If we put all of that together, by the way, we could cut pi into fifths if we wanted. It's just not as common. We can cut pi into however many equal pieces we like. So I'm just looking at the common cuts here. So let's look at a summary now of all of this. So let's look at the smallest cuts we had, which were the pi over 6's. So here's 0, here's pi, and then we've got our 6 equal cuts for pi. Okay, these are basically 30-degree rotations. So pi over 6's are 30-degree rotations. That's not too hard to remember because pi radians is the same thing as 180 degrees. 180 degrees divided by 6 is 30 degrees. Okay, so those are pi over 6's. Let's go ahead and draw all of those out again. I know it's redundant, but you can't do this too many times, especially when you're first learning. Okay, so we've got 1 pi over 6, and then we've got 2 pi over 6, but that reduces to pi over 3. So we're getting our pi over 6's and our pi over 3's now. So we got 1 pi over 6, we got 2 pi over 6, the next one's 3 pi over 6, but that reduces to pi over 2. So we're getting our pi over 2's also. So 1, 2, 3, 4 pi over 6 reduces to 2 pi over 3, 5 pi over 6, 6 pi over 6 reduces to pi, 7 pi over 6, 8 pi over 6 reduces to 4 pi over 3, 9 pi over 6 reduces to 3 pi over 2. Investigate these for yourself. Then you've got 10 pi over 6 reduces to 5 pi over 3. Then you've got 11 pi over 6, which doesn't reduce, and 12 pi over 6 reduces to 2 pi. So if we look at this, we notice that when we have all of our pi over 3's, pi over 6's, and pi over 2's, the pi over 6's are the 30-degree angles that are closer to the x-axis. Okay? Those guys are closer to the x-axis. And then our pi over 3's are 60 degrees from the x-axis, right? They're closer to the y-axis. They're only 30 degrees from the y-axis. And then of course our pi over 2's land on the y-axis. Okay, so that's nice. Now the only one of our common radian measures that are missing, which by the way, let's go ahead and summarize, pi over 3 equates to 60-degree angles, because 180 divided by 3 is 60. But we need our pi over 4's. So to get our pi over 4's, if we cut pi, the top half, into 4 equal pieces, that's going to split each quadrant into 2 equal pieces. So this is going to be our first pi over 4, our second pi over 4, our third pi over 4, and our fourth pi over 4. Okay? So what we get, this is 1 pi over 4, then this is 2 pi over 4, which reduces. This is 3 pi over 4. This is 4 pi over 4, which reduces. This is 5 pi over 4. This is 6 pi over 4, which reduces. And finally we have 7 pi over 4. And 8 pi over 4 reduces to 2 pi. So the pi over 4's equate to 45-degree angles. And they're not closer to the x or to the y, right? So the yellows are closer to the x-axis. The pi over 6's are closer to the x-axis. The pi over 3's are closer to the y. And the pi over 4's are equidistant from the x and the y. Alright, so you may want to write some of those things down, but this is really important. And I don't recommend memorizing this. Be able to do it, and you'll do it so many times you'll just know it. Okay, the memorization will be a byproduct of knowing it well.